Alright, this is card 87. We're going to talk about polygons. A polygon is a shape. Let's make that a little better. It's a closed shape made up of straight sides. Okay? A polygon is equilateral if all of its sides are the same length. A polygon is equiangular if all of its angles are of equal measure. A regular polygon is a polygon that is both equilateral and equiangular. Okay? Now we have to go over the most common polygons. Let's see. How do I want to do this? First we have three sides, and that's a triangle. Like this. Then we have four sides. That's called a quadrilateral. Okay. Then we have five sides, which is a pentagon, which like that. Then we have six sides, which is a hexagon, and looks like that. Then we have seven sides, which is a heptagon, or sometimes a septagon, just like a triangle is sometimes a trigon. And a heptagon is 7 sides, so 1, 2, 3, 4, 5, 6, 7. Let's number them, right? To make this clear. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7. Okay, let's keep going. We got a couple more to do. Let's do 8 sides, which is an octagon. Okay, and this one is tough to draw also. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now let's go up here to 9 sides, which is a nonagon or a novagon. And then we can do, now you don't have to really draw the 9-sided one, it's one of these things with 9 sides, right? Then you can do 10 sides, which is called a decagon. And then another common one is 12 sides, which is a dodecagon. Okay, so those are the most common polygons. Okay, so let's go to card 88. Oh, yeah, that's fine. Okay, let's see what we got here. The sum of the interior angles of a polygon is 180 times n minus 2, where n is the number of sides. All right? And second. Let's actually erase this for a second. And put each interior angle of a regular polygon can be found using the formula 180 times n minus 2 divided by n. And for both of these problems, n is the number of sides. So let's see. If I could do a quick example here. Let's do the sum of the interior angles of a pentagon. Now let's do quadrilateral. No, let's do pentagon. So we have the formula. How do I want to write this? Let's see. Let's make this 1, 2, 3, 4, 5, right? So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 equals 180 times n minus 2, which is equal to 180 times, remember, a pentagon has 5 sides. Okay? And now let's do each interior angle of a regular pentagon. Remember again, it's 5 sides. So this time, all my sides are really supposed to be the same length, so I'm just gonna do my best to make them look the same. So this side and this side and this side and this side and this side are all congruent, and this angle 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 are all the same. Okay? Let's get rid of this on the left here, and let's just say the sum of interior angles equals that. Now let's put over here each interior angle equals 180 times n minus 2 over n, which is 180 times 5 minus 2 over 5. 180 times 3 over 5. 540 over 5. That's 108. So each one of those angles is 108 degrees. Okay? So underneath sum of interior angles over here, let's put angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5. And so now let's actually go ahead and label each one of these angles. 108 degrees, so you can see what I mean by each. Okay, so that's good enough for that one. 89. We're going to talk about exterior angles. The sum of the exterior angles of any polygon is equal to 360 degrees. And each exterior angle of a regular polygon is 360 over n. And again, n is the number of sides. Okay? So let me show you two things on the other side. Let me think about this for a second. Alright, let's divide this in half. So let's put the sum of the exterior angles of a triangle. And let's say we had this triangle. Oops. Okay. Now, the exterior angles are found by extending each one of the sides. Okay. So for example, this could be 1, this could be 2, and this would be 3. So the sum of exterior angles is always 360 degrees, which means that angle 1 plus angle 2 plus angle 3 is 360. Okay? Now, on the other side, let's draw a regular polygon, which means that it has to have all of the sides the same length. So I'm going to draw a triangle with all of the sides the same length, about the same length. I mean, you can't be perfect. I'm going to try to draw them all about an inch. Now I'm going to extend the sides like I did in the last one. Okay, and this could be 1, and this could be 2, and this could be 3. Now in this triangle, all of these sides are congruent, and all of these angles are congruent. So each exterior, actually let's get rid of those numbers. We don't even need them. Now we do know that all of the exterior angles are congruent, so we can put the same number of arcs in each one. So each exterior angle equals 360 degrees over n, which equals 360 degrees divided by 3, which is 120 degrees. So this is 120 degrees, this is 120 degrees, and this is 120 degrees. Okay? Let's put that aside. Alright, this is card number 90, and we're going to start talking about quadrilaterals. Alright, first thing you have to remember is that a quadrilateral is any four-sided figure. Okay. You can also remember let's see. There are 6 important quadrilaterals, and they are, let's see, what do I want to do first? Just give me 1 second. Okay. They are, number 1, parallelogram. Number 2, rectangle. Number 3, rhombus. Number 4, square. Number 5 is trapezoid. And number 6 is isosceles trapezoid. Okay. Now, let's see here. If I can give you some quick sketches, or if I'm going to save that for another card. Alright, let's turn this card over, and let's just do a very basic sketch of each one of these objects. So what we're going to do is divide the card into, how do I want to do this? Into thirds. So 2 and 4. I'm going to go to 2 and 4 inches on the top and bottom. So I'm going to divide it in thirds vertically. And then I'm going to divide it in half the other direction, horizontally. So let me just get that going here. So I have 6 boxes now. Okay? So in the first one I'll draw a picture of a typical parallelogram. Okay? Okay, that's your typical parallelogram. And I'm not going to label the sides or anything. Alright, it's just a very basic drawing. The next one was rectangle, and we all know what a rectangle looks like. So I'm going to do 1 1/4. By 1. By 1 1/4. And by 1. If we want to identify it by its sides, we could put like, this is one length, this is a different length, and this side is parallel to this side, while this side is parallel to this side. We can put the basic identifiers for the rectangle in, right angles. Okay, there's more information too about them, but I don't want to overload the diagrams with too much stuff. This is rectangle. Okay. Then we can draw our rhombus where all the sides are the same length. So it looks like a parallelogram, but it's not. Because all of the sides of a rhombus are the same length, and the opposite sides are also parallel. Okay? And then the square is the one we all know, where all the sides are the same length and there are 4 right angles. So I'm going to draw all my sides 1 inch long. Alright, so now label each side with 1 hash mark, and label all the angles with 90-degree angles, and we can also do the parallel thing. Okay, so let's call this a square. Now, like I said, each one of these has more properties than just what I've labeled, but these are like some of the basic properties. Now we have a trapezoid. Okay. And for a trapezoid, we could draw something like, we can draw a lot of different things, but this is an example of a trapezoid. And the only real thing that we would label about a trapezoid is that the opposite sides are parallel. Okay? That's really its only main property. And then when we talk about isosceles trapezoid, this is the one that you're more familiar with probably. Okay, so let's say now the sides are both the same length. So if this side here is about that, then okay. So now what's special about an isosceles trapezoid is that we still have the base sides. These are called the base sides. They're still parallel. But in addition, the base angles are congruent, okay? And these sides are congruent. That's why it's called an isosceles trapezoid, all right? And there are more rules, but those are the basic ones. Now, let's just go back to the parallelogram and let's just label a few more things. We know this angle is equal to this angle, and this angle is equal to this angle. The rectangle, we've labeled that. The rhombus is the same deal. This angle congruent to this one, and this angle is congruent to this angle. And that is good enough. Oh, and then for the isosceles trapezoid, we can label this as these angles are also congruent. All right. So that's the basic information about the quadrilaterals, and let's just call this the isosceles trapezoid. Now we're going to get into the more detailed information for each one of these figures. Okay? So let's put that card aside. That was 90. Now we're on 91. And the first one we're going to talk about is a parallelogram. So let me just pull up the information on that. Okay, we'll start with the definition. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Draw my little symbol for parallel. Okay? Let's see what else we want to put for this. Alright, so before we go into the theorems, let's put the other properties. Okay, so let's put here properties. Two sets of parallel sides two sets of congruent sides opposite angles congruent consecutive angles are supplementary. Right? The diagonals bisect each other. The diagonals form two congruent triangles. Okay. Now let's try to draw a picture with all of these things labeled, which is not easy to do. All right. So what we're going to do is draw two different pictures of a parallelogram, and maybe even three. Let me think here. Let's draw three different pictures. So I'm going to start at the top. I'm going to make that. So I went in a half an inch and I made the top an inch long. Then if I skip a half inch and I skip a half inch, then the middle one, so there. So I made three 1-inch lines at the top. Okay? Now I'm going to go down a little bit. And I'm going to do the same thing, but I'm going to move them a little bit. So I'm going to go 1/4 inch in on each one. So I have 3 different parallelograms. On the first one, I'm going to label the most basic information. 2 sets of sides are parallel, so the opposite sides are parallel. Let's name this parallelogram A, B, C, D, like that. Okay. So we're also going to, so that covers the first property. Then we have 2 sets of congruent sides. So let's put 1 line here and 1 line here and 2 here and 2 here. Opposite angles are congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. The diagonal consecutive angles are supplementary. We can cover that on the first one. So let's put, let me sharpen this. We could say that AB, segment AB, is parallel to segment DC. We could say that segment AD is parallel to segment BC. Also that AB is congruent to DC. Segment AB is congruent to segment DC. Segment AD is congruent to segment BC. Then angle B is congruent to angle D. Angle A is congruent to angle C. And we can also talk about this consecutive angles are supplementary. So that means any 2 of the angles that are next to each other, if you add them up, they add up to 180. So let's try to cover all of these. So angle A plus angle B equals 180 degrees. Angle B plus angle C, so leave yourself some room here, equals 180 degrees. Angle C plus angle D equals 180 degrees. And angle D plus angle A equals 180 degrees. So those are the first properties of a parallelogram. Now there are more properties, but my picture would have gotten too clogged over here, so now I'm going to draw these other properties on this other parallelogram, and this one has to do with the diagonals. Okay, and it says the diagonals bisect each other. So that means that this piece is congruent to this piece, and this piece is congruent to this piece. So we could say that, let's call this point right here E. So I could have even drawn this on the first picture, but that would have gotten confusing actually with the angles. So we could say AE is congruent to EC, and DE is congruent to EB. Alright, the diagonals bisect each other. And then the last one says that the diagonals form 2 congruent triangles. So let's call this, let's label this A. Let's label it the same way we've been labeling the other ones, so it's a little bit less confusing. A, B, C, D. So if I drew in a diagonal this way, it would form 2 triangles, right? and triangle ABD would be congruent to triangle BCD. Now I can draw in another parallelogram. You see how long I made those? And I can draw in a diagonal this way, right? Because there's two diagonals. And let me label this the same way, A, B, C, D. So if I draw a diagonal that way, triangle ABC is congruent to triangle ACD. Let me see, ABC, doesn't matter, ACD. Okay? Those are all of your properties of a parallelogram. Okay? Lots and lots of properties. Now, let's talk about the theorems of a parallelogram. So this is now card 92. Okay? Let's see what we have here. All right. So let's see how we want to write this. Let's see. Actually, I don't think we need to write any of these. Just let me double check before I... Okay. We can now move on to the rectangle. So 92. Let's put the definition of a rectangle first. A rectangle, let me just check something. A rectangle is a parallelogram with 4 right angles. Okay? Let's see. Let's list its properties. All of the properties of a parallelogram. So it has all of the properties that we talked about for the parallelogram. Plus 4 right angles. And the diagonals are congruent. Okay? So let's see, how do I want to write this out? Alright, okay, I think I'm going to need 1, 2, 3. Let's see. Start up at the top, near the top. And I'm going to go, let's think. If I go away, let's see, 6 inches. Each one into 2. Alright, so I'm going to go a 1/4 inch in, and I'm going to draw a line to a 1/4 inch to the 2. I'll do the same thing, a 1/4 inch from the 6, and I'll go to a 1/4 inch from the 4, and then I'll go a 1/4 inch from the 4 to a 1/4 inch from the 2. And I'm going to do the exact same thing a little bit below that. So I'm going to draw 3 rectangles. I'm probably going to draw a few more later on, but I'm going to start with 3 for now, so we can get all the properties of the rectangle clearly written. Alright. Okay, so first remember it has all the same properties of the parallelogram. So it has 2 sets of parallel sides. It has 2 sets of congruent sides. Right? The opposite angles are congruent, and in fact they're all 90-degree angles, so all 4 angles are congruent. So they're all 90-degree angles. The consecutive, obviously they all, the consecutive angles add up to 180, right? We're also going to talk about the diagonals. Let's see. Alright, let's start there. And it turns out that we'll talk about this in a second, but let's go back to this first one. Let's label this A, B, C, D. So, again, we know that segment AB is parallel to segment DC. We know that AD is parallel to BC. Segment AD is parallel to segment BC. We know AD is congruent to BC. We know AB is congruent to DC. Let's see what else. We know that, let's see, how do I want to write this? We know that angle A is congruent to angle B, is congruent to angle C, is congruent to angle D. And we know that all angles are right angles, 90 degrees. They're all congruent, so they're all congruent because they're all right angles. And we know that the consecutive angles add up to 180. So angle A plus angle B equals 180. Angle B plus angle C is 180. Angle C plus angle D is 180. And angle D plus angle A is also 180. Okay? Now let's look at the second picture here. A, B, C, D. And let's call this middle point here E. First we know that the diagonals are congruent. So we know that AC is congruent to BD. Okay? We also know that they bisect each other, so we know that AE is congruent to EC, and BE is congruent to ED. Okay? And the last thing is, again, let's call this A, B, C, D. We know that triangle ABD is congruent to triangle BCD. Now we can draw another rectangle a little bit below this. A, B, C, D, and this time we'll have the diagonal going the other way, and we can say that triangle ABC is congruent to triangle ACD. Okay? So those are all your properties for a rectangle. Now let's go to the next card, where we're going to talk about, let me just check something. Let's see here, rhombus. Okay, just sharpen this. This is card 93. So a rhombus is a parallelogram with 4 congruent sides. Now let's talk about the properties. All right, so it's the first. The first one is that it has all of the properties of a parallelogram. So just like the rectangle, the rhombus has all of the properties of a parallelogram, plus it has 4 congruent sides, the diagonals bisect the angles, So diagonals bisect angles, and the diagonals are perpendicular. So those are our additional properties. Now it doesn't have the properties of a rectangle, the additional properties of a rectangle, right? It has all the properties of a parallelogram plus these three additional properties. So let's draw a couple of pictures on the back. Alright, let's see here. So we have a rhombus this time. So it's got 4 congruent sides. So if I have 6 and I use 3 and I put, let me think here. 5 to 4. Okay, I'm gonna go from a 1/2 inch to 1.5. And on the other side I'll go from 5.5 to 4.5. And now I got, I'm gonna go from 2.5 to 3.5. Okay? So now each one of those lines is 1 inch long. So what I gotta do is draw inch long lines again. Alright? And I gotta try to keep them at the same angle, because that's how a rhombus is. And obviously this isn't going to be perfect, but you just do the best you can to make them all look the same. So basically all of these lines I'm trying to draw at the same angle here. But if my ruler slides at all, then it won't be, but they'll be close. Hopefully. And now I connect all the bottom lines. So that I have okay. Now, the first thing is that the opposite sides are parallel. Now, all 4 sides are the same length, so I'm putting 1 hash mark on each segment. Let's call this A, B, C, D. Now, my angles, my opposite angles are congruent. So they're not right angles like the rectangle, right? They're congruent. Their opposite angles are congruent like the parallelogram. Let's see what other things I could add into this picture. No, I'll put that in the next picture. Okay, so that's good enough for this picture. Now let's just put the information that we have here. So first is that segment AB is congruent to segment BC, which is congruent to segment CD, which is congruent to segment DA. So all the segments are congruent. Okay? And we also know that AB is parallel to DC, and AD is parallel to BC. We know that angle A is congruent to angle C, and angle B is congruent to angle D. And let's see, is there anything else? I don't want to miss anything. Oh, and then we got the supplementary thing, right? So angle A plus angle B is 180 degrees. Angle B plus angle C is 180 degrees. Angle C plus angle D is 180, and angle D plus angle A is 180 degrees. So those are the first few properties, right? Then we have a couple of additional properties. And it has to do with the diagonals. Okay? So let's see here. We have A, B, C, and D. Now, for the parallelograms, we know that the diagonals bisect each other, so that's still true. Okay? And we'll call this E right here. Now, one of the additional properties for a rhombus is that the diagonals are perpendicular to each other, so they form 4 right angles. Right? And also, it says that the diagonals bisect the angles. So, this is congruent to this, which is congruent to this, which is congruent to this. And this little angle here is congruent to this little angle. And this little angle is congruent to this little angle. So now let's put this in some words, right? So let's put a segment AC is perpendicular to segment BD, and let's put forming 4 right angles at their intersection. Well, let's put at E, right? That makes it a little bit shorter, at E. So we can also say AE, segment AE is congruent to EC, segment DE is congruent to segment EB, and let's make this a little bit easier for us by numbering the angles. Alright, so let's label this angle 1, angle 2, angle 3, angle 4, 5, 6, 7, 8. So angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. And angle 5 is congruent to angle 6, is congruent to angle 7, is congruent to angle 8. Okay? And then we can also still have that last property of the parallelograms. Right, this goes all the way back to the parallelogram property. So triangle ABD is congruent to triangle BCD. So the diagonals also form congruent triangles, right? So that was one diagonal. And that could be the other diagonal. Then we can just say that triangle ABC is congruent to triangle ACD. Okay. So that is it for the rhombus. Now we go up to the quadrilateral with the most properties.